The placement of a 200 amp main breaker load center in a single-family dwelling's garage is governed by specific electrical codes and safety regulations. The National Electrical Code, or NEC, provides guidelines for such installations, and local jurisdictions may have additional requirements. While the NEC doesn't explicitly prohibit placing a load center on the back wall of a garage, several factors must be considered to ensure compliance and safety. Firstly, working clearance around electrical equipment is crucial. NEC Section 110.26 dictates the required working space in front of electrical equipment, including load centers. This space must be sufficient to allow safe operation and maintenance of the equipment. The depth of the working space depends on the voltage of the system and the presence of any exposed live parts. For a 200 amp service, the working space typically requires at least 3 feet of clearance in front of the load center. Secondly, the location of the load center must not be in a damp or wet location unless the equipment is specifically designed for such environments. Garages, especially in regions with high humidity or potential for flooding, can be considered damp locations. If the garage is prone to moisture, an M3R rated enclosure might be necessary for the load center. Thirdly, the load center should be readily accessible. This means it should not be obstructed by stored items, vehicles, or other obstacles. The NEC defines readily accessible as being capable of being reached quickly for operation, renewal, or inspections without requiring those to whom ready access is requisite to climb over or remove obstacles or to resort to portable ladders, and so forth. Fourthly, the NEC addresses the physical protection of electrical equipment. Section 110.27 states that electrical equipment likely to be damaged shall be suitably guarded. In a garage, the load center is susceptible to physical damage from vehicles, tools, or other objects. Therefore, it may be necessary to install barriers or guards to protect the load center. Fifthly, consider the potential for vehicle impact. If the back wall of the garage is close to the parking area, the load center could be at risk of being hit by a vehicle. In such cases, additional protection, such as bollards or concrete barriers, may be required. Sixthly, local amendments to the NEC can vary. It is essential to consult with the local electrical inspector or building department to determine if there are any specific requirements for load center placement in garages in that particular jurisdiction. These amendments may address issues such as height restrictions, specific clearance requirements, or grounding requirements. Seventhly, grounding and bonding are critical for electrical safety. The load center must be properly grounded and bonded to the grounding electrode system to provide a low impedance path for fault currents. This helps to prevent electrical shock hazards and ensures that overcurrent protective devices, such as circuit breakers, operate correctly. Eighthly, consider the location of other utilities and services in the garage. The load center should not be installed in close proximity to gas lines, water pipes, or other utilities. This helps to prevent accidental damage or interference with these services. Ninthly, think about future expansion. Ensure that the location of the load center allows for future expansion of the electrical system. This may involve adding additional circuits or upgrading the service capacity. Tenthly, the height of the load center is also a consideration. The NEC specifies the maximum height for circuit breakers and switches to ensure they are readily accessible. Typically, the highest breaker should not be more than 6 feet 7 inches above the floor. 11thly, proper labeling of circuits is essential for safety and troubleshooting. Each circuit breaker in the load center should be clearly labeled to indicate the equipment or area it serves. This helps to prevent confusion and makes it easier to identify and isolate circuits during maintenance or repairs. 12thly, use appropriate wiring methods for the garage environment. Exposed wiring should be protected in conduit or other approved raceways to prevent damage. The type of wiring used should be suitable for the environmental conditions in the garage. 13thly, follow manufacturer's instructions for installation and maintenance of the load center. The manufacturer's instructions provide specific guidance on proper installation techniques, wiring connections, and maintenance procedures. 14thly, consider the orientation of the load center for ease of access. The door of the load center should open fully without obstruction. The layout of the breaker should be logical and easy to understand. 15thly, ensure that the load center is securely mounted to the wall. Use appropriate fasteners and mounting hardware to prevent the load center from coming loose or falling. 16thly, use properly sized conductors for all wiring connections. The size of the conductors should be based on the ampacity of the circuit and the applicable NEC requirements. 17thly, torque all connections to the manufacturer's specifications. Loose connections can cause overheating and electrical failures. 18thly, perform a thorough inspection of the installation after completion. Verify that all wiring connections are tight, that the load center is properly grounded, and that all circuits are labeled. 19thly, test the operation of all circuit breakers to ensure they are functioning correctly. This can be done using a circuit breaker tester or by simulating a fault condition. 20thly, provide the homeowner with instructions on how to operate and maintain the electrical system. This includes information on how to reset circuit breakers, how to identify potential electrical hazards, and how to schedule routine maintenance. 21st, consider the aesthetic appearance of the installation. While functionality and safety are the primary concerns, the load center should be installed in a neat and professional manner. 22nd, ensure that the installation complies with all applicable building codes and regulations. This may involve obtaining permits and inspections from the local building department. 23rd, the working clearances as mentioned previously must be maintained not just at the time of installation, but throughout the life of the installation. Garages are notorious for accumulating clutter. The homeowner needs to be aware that they cannot block access to the electrical panel. 24th, the panel should be protected from physical damage. Garages often have tools, equipment, and vehicles moving around. A barrier may be necessary to prevent accidental damage to the panel. 25th, proper grounding is absolutely essential. In addition to the grounding electrode conductor, all metallic parts of the electrical system must be properly bonded together to create a low impedance path for fault currents. 26. Arc fault circuit interrupters, or RSIs, may be required for circuits serving certain areas of the garage. RSIs are designed to detect arc faults, which are a common cause of electrical fires. 27. Ground fault circuit interrupters, or GFCIs, are required for receptacles in garages. GFCIs protect against electrical shock hazards by detecting ground faults. 28. Consider the ambient temperature in the garage. Electrical equipment is typically rated for a certain ambient temperature range. If the garage is subject to extreme temperatures, it may be necessary to use equipment with a higher temperature rating. 29. Proper ventilation is important for electrical equipment. Enclosed equipment can generate heat, which can reduce its lifespan and performance. Ensure that the load center has adequate ventilation to prevent overheating. 30th, surge protection may be desirable to protect sensitive electronic equipment from voltage surges. A surge protective device, or SPD, can be installed at the load center to divert surge currents to ground. 31st, regular maintenance is essential to ensure the continued safe and reliable operation of the electrical system. This includes inspecting wiring connections, testing circuit breakers, and cleaning the load center. 32nd, ensure that the homeowner understands the importance of electrical safety. Provide them with information on how to identify potential electrical hazards and how to respond in an emergency. 33rd, if any electrical work is performed, it must be done by a qualified electrician. Electrical work can be dangerous, and it is important to have the work done by someone who is trained and experienced. 34th, consider the location of the garage door opener. The garage door opener should be installed on a separate circuit from the load center. This helps to prevent the garage door opener from interfering with the operation of other electrical equipment. 35th, ensure that the garage door opener is properly grounded. This helps to prevent electrical shock hazards. 36th, if the garage has a workshop, consider the electrical needs of the workshop. The workshop may require additional circuits for power tools and equipment. 37th, ensure that the wiring in the workshop is properly protected. Exposed wiring should be protected in conduit or other approved raceways. 38. If the garage has a swimming pool or spa, there are specific electrical requirements that must be followed. These requirements are designed to protect against electrical shock hazards. 39. Consider the location of any outdoor lighting fixtures. Outdoor lighting fixtures should be installed on a separate circuit from the load center. 40th. Ensure that the outdoor lighting fixtures are properly grounded. This helps to prevent electrical shock hazards. 41st. If the garage is used for storage, ensure that stored items do not block access to the load center. The load center must be readily accessible at all times. 42nd. If the garage is used for parking, ensure that vehicles do not block access to the load center. The load center must be readily accessible at all times. 43rd. If the garage is attached to the house, there may be additional electrical requirements. These requirements are designed to protect against electrical fires. 44th. Consider the location of any smoke detectors. Smoke detectors should be installed in the garage to provide early warning of a fire. 45th. Ensure that the smoke detectors are properly wired and maintained. Smoke detectors should be tested regularly to ensure they are functioning correctly. 46th. If the garage is detached from the house, there may be different electrical requirements. These requirements are designed to protect against electrical shock hazards and fires. 47th. Consult with a qualified electrician to determine the specific electrical requirements for the garage. A qualified electrician can assess the electrical needs of the garage and ensure that the installation complies with all applicable codes and regulations. 48. Proper planning is essential for a safe and reliable electrical installation. Take the time to carefully plan the installation before beginning any work. 49th. Use high-quality materials and equipment. This will help to ensure the long-term reliability of the electrical system. 50th. Follow all safety precautions when working with electricity. Electricity can be dangerous, and it is important to take all necessary precautions to prevent electrical shock or fire. Ultimately, the decision of whether to place the 200 amp main breaker load center on the back wall of the garage depends on a thorough assessment of these factors and compliance with all applicable codes and regulations.